Good afternoon, sixth grade class. It's great to see you, metaphorically. I'm glad you joined in. Thanks for stopping by. It's great to see Louie, Jordan, George, Jackson, Jordan Balsamo, not Sarah Reinhardt, Leo, Jacob Quinn, Silas is in the house, Laura Petruska is here, Kate Stewart, Drew Ashley, Brian Bolden, God bless you all if I'm missing people. Harrison Jeffrey, no. Opening song, bumper music, bad, sad. So, apparently YouTube can tell if you play music on their live streams. And if you do, then they send you a message that says that you have violated their copyright rules. And then they take your video offline, which is bad. They did that to me last time I played a song for 8th grade, and I didn't play a song for 7th. But as I was doing 7th grade's video, the YouTube came up, shut down the 7th graders one, and just took it offline and said I was bad. I was a bad person. So I don't want to risk copyright violations with songs. Thank you, YouTube, for making our life a little easier, being able to stream, and a lot more boring by being more concerned about a few pennies that they could have been making off of a song being played. So kind of hum a song in your head. Does everybody understand about that? All right, here we go. We're going to skip ahead to solids today. So if you're taking a look on your iPad or someplace else, we're taking a look at solids today. If you did the chemical physical reaction quiz, that's great too. I do expect you to do it and take the quiz, but I want to move ahead to solids. I'm thinking that we're going to be gone a lot longer than we think, and so I'm going to cover essentials. And one of the essentials that we absolutely have to cover is solids. So on your Chem for Kids, we're going to take a look at solids first. Is everybody good with that? All right, here we go. Anyhow, it starts off innocuous enough. Innocuous means it's not poisonous, it's non-threatening. And then they remind us what solids are. You already know what solids are. Molecules are locked in place. They can't move away. They can't move over and around. Solids have many different characteristics. In your own experience, you've probably encountered the fact that some solids can be soft. A bunny rabbit's fur is a solid, but it's very soft. Diamonds are incredibly hard. So some solids are soft, some solids are hard, right? Some solids are huge, like the earth is a solid. Some solids are tiny, like a grain of sand, right? Does that make sense? So they have many different characteristics, but the big deal is that their molecules are close together, which means they have high density, and their molecules are locked in place without the freedom to move around except for one kind of motion, and that is vibration. And of course, every solid has lots of motion. Remember in our quantum world song, the world is a gigantic mess of jiggling things. Even the most solid substance, diamonds, metal, steel, iron, is still vibrating crazily. Although in the quantum world, you and I don't sense it, but it's there. All right. So they took a look and they decided that they would throw in mixtures here. Solid mixtures are when you have two or more different kinds of solids that have been pressed together or bonded together, right? So a solid mixture is when you have two or more different kinds of solids that have been pressed together using high pressure, or in other words, squashed, literally, or they have been bonded together. They gave you an example of solid mixtures. Their example here was concrete. All right? When you walk on a sidewalk, or if you drive down a road that's made of concrete, And Silas would know a lot about concrete and cement and the difference between those. But concrete, they said, is a good example of a man-made solid mixture. Concrete has lots of different sized solids in it and different kinds of solids. If you were really interested in doing this and you had the time, you could go and break out a piece of concrete, and using hammers and tweezers and tools, you could break out all the different parts of it. You literally could separate the parts out. And that's the big deal about mixtures, is that you can separate the things out. All right. While we look at solids, I told you yesterday that we would talk a little more about crystals. And so we're going to do that today because it's on the solids study guide that they're making you look at today. It's its own little thing. All right. On the other end of the spectrum is something called crystals. All right. And so when molecules form solids, they can lock themselves into place in one of two ways. All right. So look at that. Silas is telling us that fine aggregates and coarse aggregates and cement would be solids. And he is right. Fine means tiny, coarse means larger. Aggregates are the little pieces that make it up. So Silas, thank you for teaching us there. When solids form, the molecules can either just randomly become frozen, right, wherever they were at. They're vibrating, they're a liquid, they're moving over and around, and suddenly you reach the point at which they no longer have freedom, which is called the freezing point. And when they freeze, they're just locked in random locations. So some solids have their molecules locked in random locations. And that's a really good note to take. When solids form, some solids have their molecules locked in random locations. If these are solids that have their molecules locked in random locations, then we say that these solids are amorphous. amorphous. Let's take a look at that again. An amorphous solid. amorphous. It's not in the study guide, but it becomes a question on the quiz. I've noticed they do that on this study guide. They'll quiz you on stuff that appears elsewhere or not at all. So, we'll give this study guide a B+. It has a lot, and it's exactly what we're studying, but it's arranged oddly. Amorphous solids. amorphous. Let's do word attack. Take that word apart. The letter A means not, right? We talked about that already. So if I put A in front of a word, A means nope, not, opposite. The next part of amorphous is morph. Morph means shape, right? So if I say amorphous, it means without shape. What kind of shape? Regular repeating patterns, all right? So an amorphous solid has its molecules that are arranged in really random ways, all right? And that's many, many solids. Believe it or not, you probably think, well, glass looks like a crystal. Glass isn't a crystal. Glass has its molecules arranged amorphously. If you think about glass, it's kind of an amazing material, isn't it? It's one of the few substances that humans made that's invisible, right? Like we think of invisibility and an invisibility cloak. When you make glass, the whole point of glass is that you don't see it. And we'll talk about how you don't see glass at another time. But glass, most forms of glass are amorphous solids. Does that make sense to you? The other way so molecules, when they form, can have their molecules arranged in just bizarre, irregular patterns. And those are amorphous solids. At the other end of the spectrum, crystals. crystals. So a note that you're taking now is crystals. At the other end of the spectrum, another way to think about what solids are when they arrange their molecules. Amorphous solids, randomly arranged molecules. Crystals, regular repeating patterns. We talked about this a little bit yesterday. RRP. In other words, the crystals might be all lined up parallel, a row after row, or maybe they're arranged at exactly 90-degree angles to one another everywhere. And that's, by definition, a crystal. A crystal has a regular repeating pattern all throughout of some sort of decided geometric spacing. For instance, salt, table salt, the kind that's on your McDonald's fries, the kind that you cook with, the kind that's in the shakers at your kitchen table perhaps, or maybe some families don't like it. Salt is made of sodium and chlorine. You know that sodium donates one electron, chlorine takes the other. When they do, each sodium and chloride lock into each other at 90 degrees. So everything about a piece of salt is 90 degrees. If you look at salt crystals underneath the dissecting scope, and let's try to do that when you all come back. Salt forms little tiny what shape? Have you ever seen little tiny pieces of salt on your live chat? What do they look like? Little tiny pieces of salt. What shape is it? Yeah, thank you, Drew. They're cubes. They're squares, and it's weird. And you ask yourself, well, why is that? No, they're not spheres. They're cubes. They're squares. Yeah, they're cubes. They're squares. So what's the underlying reason for it? Well, the underlying reason is that when sodium and chlorine come together, they bond at 90-degree angles. So all throughout a piece of salt, you have regular repeating patterns. The geometry is 90 degrees, and it's everywhere. It repeats, therefore salt is a crystal. Sugar does the same thing. Sugar forms crystals. I don't know if you've ever watched sugar grow. If you've ever crystallized sugar, it's really cool. It grows in very predictable ways. All right, so amorphous solids versus crystal solids. All right. And then they want to talk to you about allotropes. So let's write this word down. allotropes. 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 All right, so what if I could take an atom, and when it forms regular repeating patterns, what if it has a choice? What if sometimes it does one regular repeating pattern, but sometimes it does another regular repeating pattern? Maybe sometimes it does a third regular repeating pattern. If I looked at all of the solids that it was forming, well, I would know that they are all identical in terms of their ingredient. But if I looked at how those solids behaved, the different structures, the different geometries really will give those solids different characteristics and properties. Shape, geometry means a lot. Knowing that I can take atoms, and sometimes when they bond, they might be at 90 degrees. Sometimes when they bond, maybe they're at 45 degrees. Maybe sometimes they're at 120. It depends on the conditions. Again, at the end of the day, if I looked at the 90 degrees, 45 degrees, and the 120 degrees, if I asked myself, what are they made out of? Well, they would all be the same atom. The difference, the geometry, the shape, the bonding angles. So we say that materials or substances that are made out of the exact same atoms but differ only because of the shape of their crystals, those are allotropes. allotropes. Materials made out of the same atoms which differ only because of the geometry of their angles. You actually have experienced this in life. Yay, Hayden. All right. You've experienced this in your life. For instance, carbon atoms. If I take nothing but carbon and I put it under extremely high pressure, so the carbon that ashes are literally ashes. Usually if you have ash in a fire, the majority of the ash is just carbon atoms, right? One of the most abundant atoms on the earth is carbon. If I take carbon and I put it under extremely high pressure, the kind of pressure you'd be under if I had a layer of carbon deep under the earth, 13, 14, 15 miles, and the layers of the earth just compacted it down for a long time. Well, if I really smash carbon down, you're right, Drew, I end up with diamonds. It forces the carbon atoms into a tetrahedron, right? Which means they form shapes based upon having 4 atoms next to each other, sort of like a box. If I take those, you don't have to know that, but you do need to know that I can take carbon and smash it together and make diamonds. I can take carbon and smash it together with just a little bit of pressure, and what do I get? Pencils! Well, not literally pencils, not the eraser, not the wooden outer casing, but the graphite, the gray part, the part that I don't like in my eyes. Graphite is just carbon atoms. Are they the same as the carbon atoms in diamond? They are. What's the difference? The way that they're arranged. They're arranged in hexagons as opposed to the tetrahedron shape of diamonds. And again, you don't have to know that. Good extra credit question, but no big deal. But you do need to know that graphite, the gray stuff in a pencil, and diamonds, same material, identical. What's the difference? Pressure. Put a lot of pressure on carbon, you get diamonds, clear and see-through. Not much pressure, you get, of course, graphite, Graphite, the gray stuff inside of pencils, graphite, right? So graphite and diamonds are allotropes, all right? They're allotropes. Well, let's take a look at the quiz together, the solids quiz. In question 1, what's the term used to describe the phase change as a liquid becomes a solid? You know that as a liquid becomes a solid, there's just one term for that phase change, freezing. The point at which the molecules stop moving is the freezing point. So, I will click freezing. All right. Next question. When a liquid is cooled very quickly, it always forms a crystal. That's nowhere in the study guide, and they mention it in no area. If I take a liquid and cool it, I'm going to form a solid. But whether or not I cool it fast or slowly doesn't necessarily control whether it's a crystal or not. So they're saying if I cool something fast, I'm going to form a crystal. That's too simple. If you could form crystals simply by speeding up the rate of freezing, by dropping the temperature quickly, you could form crystals out of everything. The interaction of the molecules is way more complex than that. And so the answer to the idea that if you cool any liquid quickly, you get a crystal is wrong. I'm going to click false, and I'm right yet again. Okay. The next question, question 3, solids usually expand by large amounts when the temperature rises. Well, all things, when you increase the temperature, they vibrate more. And as they vibrate more, they tend to take up more space. Of all the phases of matter, solids, liquids, gases, plasmas, and throw in the BE if you want, the Bose-Einstein condensate, of all the phases, because solids are locked in place. Although they can vibrate, they won't take up a whole lot more space. So the idea that solids expand by large amounts when the temperature increases, that's not true. Solids, by definition, do not change their shape easily. By definition, the molecules are locked in place. They're not going to change their shape. We know that solids have a high density, right? That's the definition of a solid. Everything is together and close, right? And so, for question 3, none of the above. Hooray. The next question, amorphous solids. Now, they're throwing out information on the quiz that they never taught you. Yay! So let me go over some of it for you. Amorphous solids, they say, are more flexible at higher temperatures. And that's true. Amorphous solids are more flexible at higher temperatures. You think of certain plastics. Amorphous solids, they do include glass. All glasses, not just glasses that you wear, all glasses, or these, all glass is an amorphous solid. And amorphous solids, remember I told you that shape controlled a lot of characteristics? Because amorphous solids have some molecules like this, and some are like this, and some are like this, and some are like this. That's going to affect their melting point. Some will melt at one temperature, and some will melt at different temperatures. All right, thank you. I look snazzy. So really and truly, amorphous solids, they are more flexible at higher temperatures. Amorphous solids absolutely include glass and all glasses. That's the king of the amorphous solids. Amorphous solids, because they have such a wacky collection of molecules arranged in different ways, they will have different melting points. So the answer for question 4 was all of the above, I believe. And yes, it is true. Question 5, which is generally the densest state of matter? You know this. Density is mass over volume. And if I'm going to take a solid, lock everything in place with very little empty space in between the molecules, they will be the most dense state of matter. Solids will be. And we'll put up here solid, and they're telling us yes. Let's see, it says all solid forms of an element are crystals. No, not all solid forms of crystals are elements. That's false. Solids made from ionic compounds are usually hard and brittle. In all honesty, you do not have to know this. An ionic compound means that we're going to form an ionic bond. I'll teach it to you really quickly. You actually already know this. See if you get it, and you'll be like, oh, I already contained this knowledge. I am smart. You already know what an ion is. It's an atom that is charged because it's either lost an electron or it gained an electron. An ionic compound or an ionic bond, those are molecules that are formed because atoms that wanted to give an electron away, they met an atom that wanted to take it. And they're going to form a compound or molecules. For instance, salt, NaCl. Na wants to give an electron. Chlorine wants to take an electron. So they meet. It's a marriage made in heaven. And they bond. NaCl at 90 degrees over and over and over and over and over again until you have a chunk of salt. Salt is an ionic bond. Really and truly, anything from group 1A and 2A that's bonding with anything like group 5, 6, 7A, especially 7A, those are going to form ionic compounds. And ionic compounds, whenever you think ionic compound, I want you to think table salt, a rock of salt, a rock salt that you'd put on your driveway or that you'd purchased to make ice cream. Has anybody ever made ice cream at home? You know you have to get salt to make that, and I'm sure you've tasted it. It's terrible. It's horrible salt. It's bitter and it tastes like metal, and it's just like you're being poisoned, because you sort of are. How many of you have made ice cream at home and you had to buy that big rock salt for it? Hayden has. Hayden's tasted it. It's disgusting. Yes, it is. Luke has. Harrison has. Making ice cream. You know what we should do when you come back, just to celebrate all of us seeing each other? Oh, Carmen has an ice cream maker. We need to make ice cream, but with liquid nitrogen. You take a whole bunch of cream, vanilla, flavoring, sugar, brown sugar. Oh, you use NaCl? All right, Laura has. You usually don't use table salt, but you can make ice cream with liquid nitrogen. Like, we made about 5 gallons of ice cream just by mixing all the cream and the brown sugar and blah, blah, blah together. And then we nuked it with liquid nitrogen, and it froze like in a heartbeat. It was so good. We should do that. All right. Anyhow, ionic compounds, salt. And the question says, solids made from ionic compounds are usually hard and brittle. Salt is hard. Brittle means that if you hit it, it will crack easily. And I think if you've ever noticed, if you take salt and hit it with the hammer, it cracks easily. So table salt is hard. Table salt is an ionic solid. It represents all. Yes, we did, Hayden. Oh, you did it in science fair camp? I thought you said we did it in daycare camp, because we did it 2 years ago. We actually made too much ice cream, as if there can be such a thing. All right, so solids made from ionic compounds are usually hard and brittle. True. Next, metallic solids called alloys are made of one extremely pure element. The word alloy means a mixture. Whenever you hear the word alloy, you're mixing things together. Again, they're quizzing you on something that wasn't in their material. Why do they do that? I don't know. But anyhow, alloys are things that are mixtures. So they're saying metallic solids called alloys are made of one pure, no, wrong, because alloys are mixtures. So here we go. It's false. Next question, which of these is a type of solid? Ionic, metallic, amorphous. All right, they didn't teach you metallic solids, but there are such a things. There are ionic solids and they are amorphous solids. All of them are types of solids, but you don't have to know that for a quiz or a test. But you do need to know that every solid they mentioned is a kind. I told you what an ionic solid is. Great extra credit question. You don't need the other to need the other two. Last question. Crystals are irregular organizations of molecules. Oh, my friends, you know that crystals are regular repeating patterns. Well, look at that. End of the quiz, and it's 1:30. Our time together in terms of teaching is at its end. I'll hit false. I got 10 out of 10. Hopefully you'll get the same or something close before you send it in to me. All right? Let's do 15 minutes of logistics, and then I'll let you go. Logistic 1. Tell me 1, 2, 3, 4, 5. 1 is I have no idea, and a 5 is, yeah, I get it. Today we talked about amorphous versus crystal solids. Amorphous, they're randomly shaped, or randomly arranged. Crystal, regular repeating set patterns of the molecules. All right? We dug down deep into that. We talked about freezing point. We talked about allotropes. And we looked at ionically bonded materials, but you don't need to know that. Are we good on that? How's everybody doing? Everybody's reporting in. Good, good, good. Excellent. And feel free to say a 1 if you're confused. No one's in trouble for not knowing, clearly, and we're learning in a weird way online, staring at my head, which is probably better ways to do this. But thanks for playing. All right, next, in terms of your homework, you would do that quiz that I went over with you. All right. And now we're at the time for questions. Is unhardened cement considered a solid or a liquid? You know, that's like saying, is unhardened ice considered a solid or a liquid, right? Or is unhardened metal considered a solid or a liquid, right? And that it changes phase. Cement, as far as I know, doesn't really dry, it cures. And curing means that there's some bonding that's going on inside of it. That's why you can pour cement underwater and it hardens, right? Like if I'm going to build a bridge, I have to pour cement and then it hardens underwater. So it cures as opposed to dries. All right, any other questions? Yeah, and concrete sets, not cement. Look, I dribbled. So sorry that you had to witness that. All right. No other questions? All right, good. All right, logistics. Thing one, I promised that this week I would teach Monday, Tuesday, and Wednesday, and we'd take a break Thursday and Friday. Now, I said we would see what next week looks like. And in all honesty, I'm probably going to teach 5 days next week if I'm feeling okay. I still feel kind of yucky. I need to go home and rest. But what are you going to be doing? Well, you should be busy. Many of you were invited to the Kentucky State Science Fair. If you were, I do expect you to attend. Attending this year is going to be electronic. They should have already emailed you information about registering. Today is the last day to register. And I do need everyone to register if you've been invited. Why is that? St. Francis of Assisi is like the only school representing Louisville Regional Science and Engineering Fair. It would not shine a good light on you, on me, on the school if our school is LRSCF and we just bailed on the Kentucky State Science Fair. When the going got hard, we gave up. No, please don't give up. So you should have received emails already. If you haven't, text me. I know you did, though. I need everybody to register. And then they're going to ask you to make a PowerPoint. It's easy, of your board. Just get a camera, take pictures, go to PowerPoint, and load everything in. They want to see each page of your board, each page of your graphs. And the beauty of PowerPoint is you can add text to explain anything so nothing is confusing to the judges. Suddenly, that is your homework. Is instead of having to look at my head on Thursday and Friday, you guys will be registering for Science Fair, finishing that today, and then doing your PowerPoint. And in doing your PowerPoint, that sort of forces you to begin practicing your speech, and that's what you need to do. Because they're going to do Science Fair by Zoom. Zoom is a thing just like this, except you can see them and they can see you. So you'll see the judges staring back at you. Probably not like that. That'd be creepy, right? And they can see you, and they'll have your PowerPoint, and you will be able to do your speech. I think they're giving you about 8 minutes. Check and see, all right? And then you'll compete. Sound good? Okay. Again, if you were invited, my expectation is that you'll go. Your 14-year-old self will be thanking you. The school thanks you. I thank you. Your parents thank you. It's a little bit of extra work, but that's why I'm giving everybody Thursday and Friday off. If you're not going to go, then you have Thursday and Friday to catch up. You could move ahead on science if you want to, or you could take a break and catch up. I know you have a lot of language arts and math as well, and Check Schoology. I might post extra credit YouTube videos to take a look at. And then if I feel better, I might meet you all again Friday just to talk, have a class meeting, see where you're at, talk about what you're learning, see if you have any questions, see what we want to do for next week. But if I disappear because I'm sick, I'll be here next Monday at our 1 o'clock meeting time teaching you science. Sadly, I can't have bumper music. I was so excited about bumper music because YouTube says we need to be boring. Thank you, YouTube. Are we good? Yeah, I think you should be in front of your board, but you should email them and find out. Jordan, you retracted your message. Is everybody good? All right. Today, don't worry about it. I do that all the time. Listen, today's the last day, midnight, to register for that. Some of you mentioned that you wanted to go to the Kentucky Junior Academy of Sciences Science Fair. The registration was today, March 18th, but they've pushed it back to March the 28th. If you go to Google and type this in, now can you hear me? So sorry. Go and type in Kentucky Junior Academy of Sciences. It's a different science fair. I think you'd like it. And chances are you'll be delivering it by Zoom at home, so there's no having to go anywhere, right? And go check it out. You know, putting lots of stuff in your resume so that when you apply to high school, you have all these, like, look, I'm amazing stuff. Is never bad. Doing a little bit of work now. Look, all of your science fair projects are freaking amazing. You have gold in your hands. Use it to buy stuff now while it's worth it. This year's science fair project didn't worth anything. You had to make a new one. But this year, it's worth a lot. It's worth recognition. It's worth awards. It's worth, even if you just sign up for this and go and you don't win, you still say, I was a participant in the Kentucky Junior Academy of Sciences. So it's pretty cool if you want to think about doing that. If not, I get it. Not a problem. But if you got nominated for the Kentucky Science Engineering Fair, I do expect you guys to go. Are we good with that? All right. Any questions? Any comments? I wish I had bumper music to take us out, but I'm afraid of doing that because they just killed my other video in the middle of it as a form of YouTube punishment. Anyhow, God bless you. Remember, while we're doing this, the world sort of turned upside down. Not since 1918 has the world faced this kind of pandemic. People are responding in different ways. Our idea is to keep our world as sane as we can. And what do you do to do that? You anchor yourself firmly to the things that matter. In a world which is being turned upside down, you anchor yourself to love. You anchor yourself to family and kindness and patience and gentleness. And that part of your world won't be turned upside down. You anchor yourself to education and you say that school matters, learning matters. I know it's going to be okay. I know, don't worry. God love you, Hayden. I know you've been scarred by judges. We're in the middle of fixing that anyhow. So anyhow, let's go do this. Let's be good to one another. May God bless you. May God bless each of your families. May you work to lift everyone around you up. Help your parents out. This is hard for them too. It's hard for your neighbors. One of the things we can do if we're in isolation is pray. We believe that somehow our words move God's attention. I don't know how it works. There's no physics to it because it's faith. But we believe that praying moves the attention of God towards our heart, and hold the people who need love in your heart. Your mom, your dad, your moms, your dads, whoever it is that is your family, your neighbors, those with the COVID-19 illness, and all of us as we try to navigate this world that is retreating away from a pandemic and hoping for the best. Anyhow, God bless you all. Always great to see you online. I know it's not real, but and I miss you. I miss you lots. Hold you in my heart until the next time I see you. If you have questions about science fair or anything, text me. Check Schoology in case there's extra credit. Check Schoology in case we just pop online and we all meet Friday. But unless I'm deathly ill, Monday, Tuesday, Wednesday, Thursday, Friday of next week, I'll see you at 1. Why? Because we're learning. We're learning a lot. We're filling our brains. We're going to be smart. God bless each of you. Take care. And fly. Be free.